Alright, welcome back everyone. We're starting the second semester here, and this is the first topic in that semester. We're going to be looking at angles of polygons. So, to start with this, a polygon is just any figure. Doesn't matter how many sides, obviously it has to be a closed figure. You've got two things called convex and concave. We'll get into those a little bit later. But these angles of polygon are what we're going to be introduced to today. And we're going to start with a diagonal. Now, a diagonal is a segment that connects any two non-consecutive vertices. Now, remember, the vertices are the points where two segments meet. So, diagonals are the parts that connect those. So, if you think of where these red lines are starting from and ending, they are creating diagonals. Okay? Those are non-consecutive vertices. Now, what that does is it takes this five-sided figure and breaks it into three separate triangles. Now we know in any triangle you have 180 degrees. Well, this creates three triangles, so between those three triangles they're going to add up to 180 times 3, or 540 degrees. Now what this does, it leads to a theorem. It's called the polynomial interior angle sum theorem. It says the sum of the interior angles of an n-sided convex polygon is 180 times n minus 2, where n again is the number of sides. So that example we just looked at has 5 sides. So if you were to take 5 minus 2, that's 3. Notice that's how many triangles we created in that five-sided figure. We multiplied that by 180 to get the 540. So if you were to add up all the angles, so where I'm creating these orange circles, if you were to take those 5 angles, add them together, they would add up to 540 degrees. Now, when we have figures, some of them have specific names, some of them don't. Okay, so obviously a triangle has 3 sides, quadrilateral is 4, pentagon is 5, hexagon 6, heptagon 7, octagon 8, nonagon is 9, decagon is 10, hendecagon, sorry about that, hendecagon is 11, dodecagon is 12, and then from there we just call it an n-gon. So 13 sides would be a 13-gon. 15 sides would be a 15-gon. Okay, so when you read these words, that's what they're talking about. Alright, so let's try an example. It says, find the sum of the interior angles of the following figures. And we're going to start with a convex heptagon. Now, heptagon means 7 sides. So we're going to take our formula, which is 180 times n, which is 7, minus 2. Or you're going to take 180, multiply that by 5, and this works out to be 900 degrees, and there's your answer. Alright, take a second, pause the video, and try the convex dodecagon. Okay, dodecagon is 12, so you're going to take 180 times 12 minus 2, which is 180 times 10, or 1800 degrees for that figure. So that's what this is talking about. It allows us to look at a few different figures and solve some problems that deal with those. But that's a very useful formula that you're going to see. Alright, here's how we can put this dealing with some algebra. So find the value of x. So I here have a 4-sided figure. Okay, so this is a 4-sided quadrilateral. I know, based on my formula that I just looked at, that this is going to add up, or all of my angles together are going to add up to 180 times 4 minus 2, or 180 times 2, which is 360 degrees. So I've got 4 angles here. If I take all 4 of these angles and I add them up, so I've got 3x plus x plus 90 plus 90, all 4 of those have to add up to 360 degrees. And from here you just solve it. So, whoops, alright, 3x plus x is 4x, so I've got 4x plus 180 equals 360. I'm going to start solving for x, so I'm going to subtract 180. So those cancel out. You got 4x equals 180. Divide by 4, and that leaves you with x equaling 45 degrees. And that's your answer. So here this would be a 45 degree angle. This would be a 135 degree angle, just taking 3 times 45. Alright, using that same concept, please pause the video, go through, and try this second example. Okay, so this is a pentagon. Pentagons have 5 sides. So you take 180 times 5 minus 2, or 180 times 3, which is 540 degrees. So all of my angles here have to add up to 540 degrees. So I've got 2x plus 2x plus 3x plus 14 plus 3x plus 14 plus 142 has to equal 540. So we're going to do some combination of like terms. So you take 2x plus 2x plus 3x plus 3x, add those all together, you got 10x. Okay, add your 14 and 14 and 142, that gives you 170. That's going to equal 540. Okay, we're going to subtract 170 from both sides. So you end up with 10x equals 370. Divide by 10, and x equals 37 degrees. And now if you want to go back and actually figure out what each of these equals, you could substitute in. So 2 times 37, this would be a 74 degree angle. The second one, if you do 3 times 37, and then you add 14 to it, it's going to be a 125 degree angle. And since these are the same, you could check that. And now adding all of those up should give you 540 degrees, and they will. Alright, so that's how you're going to use that formula. Now the next thing we're going to look at is kind of reversing this. They're going to tell you that you have a figure that has an interior angle of 135 degrees. We want to find how many sides this figure has. So here's what we're going to need to think about. I've got my formula. It's 180 times n minus 2. We know that formula there. But what that equals is the total angles of the polygon added together. Well, the key word to this is regular. Regular means all of them are the exact same. So if you have all of those angles being the exact same, you would take 135 times however many angles there are. So you end up with this formula. And so you solve this out. So I've got 135n equals, now I'm going to distribute here. This gives me 180n minus 360. Start getting your n together on the same side. So I'm going to subtract 180 from both sides. Those are gone. That gives me a negative 45n equals a negative 360. Divide by a negative 45. And what that's going to leave me with is an n value of 8. So this is an 8-sided figure, or an octagon, that is regular, meaning all of those are the same, and so those angles would be 135 degrees. Alright, so that's how we're going to use that formula. Now the final thing in this section is what's called the polygon exterior angle sum theorem. Now what this says is if you add up all the exterior angles of a polygon, you're going to get 360 degrees. Okay, so the exterior angles are the ones that are created when you extend a side. So I took this side of this polygon and extended it out, and it gives me this angle right there. Okay, so those are all the exterior angles. So you see this one, this has a 6-sided figure. It can be any polygon, doesn't have to be 6-sided. Okay, but if I add up all those, so 1, 2, 3, 4, 5, 6, no matter what, I'm going to end up with 360 degrees. Alright, so let's look at this problem, see if we can solve it out. It says find the value of x. Well, what you notice here, this is a 4-sided figure, and I've got 4 exterior angles. Well, because of that theorem, it says that if I were to add them all up, so I got 6x plus 9x plus 2x plus 139, I will end up with 360 degrees total. Okay, so I'm going to take this, combine my like terms. So 6x plus 2x plus 9x is 17x. I'm going to subtract the 139 from both sides, and that gives me 221. Then I'm going to take and divide by this 17, and that tells me that x is going to be 13, and there is your final answer. And as always, if I want to know specific angles, I can then substitute them back in. Alright, that's the end of this section. If you have any questions, let me know. Otherwise, give your assignment a try, and I'll talk to you soon.